Em 6 de outubro de 2005, uma grande nuvem de vapor inflamável explodiu nas instalações da Formosa Plastics Corporation, na cidade de Point Comfort, na costa do Golfo do Texas. O acidente teve início quando um veículo bateu contra uma válvula de uma tubulação pressurizada contendo propileno líquido. As chamas do incêndio resultante atingiram mais de 150 metros de altura e danificaram significativamente uma grande unidade de produção da fábrica. A explosão inicial derrubou vários operários ao solo e causou ferimentos em 2, sendo que graves em um deles. 14 operários sofreram lesões leves. Formosa evacuou todo o pessoal do local. As autoridades locais criaram abrigos para a comunidade de Point Comfort e evacuou alunos e a equipe de uma escola primária nas proximidades. A US Chemical Safety Board, Comissão Americana de Segurança Química, investigou o acidente e emitiu um estudo de caso que inclui sugestões e recomendações de segurança. O complexo de Point Comfort, que cobre 7.200 km², é a maior instalação da Formosa nos Estados Unidos. Ela emprega 1.400 empregados em regime integral e 400 prestadores de serviços. O acidente ocorreu no pátio denominado Olefins 2, que usa fornos para a conversão de líquidos em gás natural ou nafta em produtos tais como propileno ou etileno.
The fire and explosions at Formosa's Point Comfort plant began with a very simple event in which a valve was struck by a vehicle. But the result was a massive fire that forced a large chemical process unit to shut down for 5 months.
Our investigation focused on how this facility was designed to protect against major fire hazards. We found that improved design practices and protective clothing could have reduced the impact of this accident. The accident occurred on October 6, 2005, inside a chemical process unit with miles of piping, hundreds of valves, and several large vessels containing highly flammable liquids and gases. On the day of the accident, a forklift was towing a trailer loaded with air cylinders used during plant maintenance. Needing to reverse direction, the driver backed the forklift and trailer into an opening between 2 columns supporting a pipe rack. As it pulled forward, the right front corner of the trailer struck a valve protruding from a strainer in a piping system containing high-pressure liquid propylene. The valve was torn from the strainer. Highly flammable propylene began shooting from the nearly 2-inch diameter opening, creating a large pool of liquid and a vapor cloud. The cloud rapidly expanded to engulf a large section of the unit. An operator heard the release, saw the fog-like vapor cloud, and immediately notified the control room.
Os operadores do painel de controle iniciaram a paralisação da unidade e descarregando os gases inflamáveis das tubulações e equipamentos para o sistema de flare, onde eles poderiam ser queimados com segurança em cima de torres. Enquanto isso, conforme mostrado nesse diagrama da tubulação, o propileno líquido continuou a fluir da torre de destilação através de válvulas manuais para o filtro, onde ocorrera o vazamento. Não havia válvulas automáticas que pudessem ser operadas da sala de controle para interromper o fluxo de propileno. Operadores do lado de fora da sala de controle tentaram chegar às válvulas manuais, mas a nuvem de vapor que crescia rapidamente os forçou a se retirarem.
Since the design of the plant did not include remotely controlled valves for isolating equipment, the operators had no way to stop the flow of propylene. Several minutes after the leak began, the vapor cloud ignited. This aerial video, taken by Houston station KHOU TV, shows how large the fire grew within the first few hours. These pictures show the damage caused by the burning propylene under the pipe rack and under the side of an elevated structure that supported a number of vessels, heat exchangers, and relief valves. As the fire continued, the side of the structure collapsed, crimping pipes leading to the flare system. This prevented gases from being safely burned. Instead, pressurized flammable gases ruptured piping and equipment and burned throughout the unit. The company's emergency response team monitored the fire for 5 days while flammable chemicals in the unit continued to burn. About 7 million gallons of water were used to cool vessels and contain the fire.
The CSB investigation noted that neither of the burned workers had been provided with flame-resistant clothing, even though they worked in an area where flash fires could occur. The propylene piping involved in the accident protruded into an open area. The CSB found the company did not have adequate vehicle impact protection, such as concrete posts to protect pipes and valves.
The CSB found 3 principal lessons from this accident. Companies should protect vulnerable equipment from vehicle impact, extensively fireproof structures used to support critical piping, and provide workers with flame-resistant clothing to protect them from flash fires. Formosa purchased the design for the olefins unit from an engineering contractor, Kellogg Brown & Root. As specified in the design, some steel beams and columns were fireproofed with a concrete coating, and those survived the fire. However, there wasn't any fireproofing on the structure that supported critical piping to the flare system, and that structure collapsed. The loss of a flare system can lead to excess pressures that burst equipment, causing uncontrolled releases of flammable gases and endangering the lives of people who respond to an emergency. Finally, companies should plan for potential releases of hazardous materials by installing automatic isolation valves at strategic locations. Automatic valves can make the difference between a minor event and a catastrophic loss.
The CSB issued formal safety recommendations to the company, the plant design firm, and a leading industry safety organization. These recommendations are aimed at preventing similar accidents and reducing their consequences.
Recomendamos que a Formosa Plastics Corporation dos Estados Unidos revise suas normas e procedimentos de análise de riscos. A análise de riscos deve considerar riscos de impacto de veículos, aço estrutural à prova de fogo e mecanismos para controle de liberações químicas catastróficas, tais como válvulas de isolamento por controle remoto. Além disso, recomendamos que a companhia exija o uso de trajes resistentes às chamas em unidades que tenham risco de flash fires. Recomendamos que a Kellogg Brown & Root, a companhia que projetou a instalação da Formosa, utilize os padrões de segurança em uso ao projetar novas instalações, incluindo padrões à prova de fogo. Nós solicitamos à principal organização de segurança, o Center for Chemical Process Safety, o Centro de Segurança de Processos Químicos, a tornar mais rígidas suas normas de avaliação de riscos, incluindo riscos de impactos de veículos e isolamento de equipamentos durante emergências.
As you've seen, a minor event like a vehicle collision can have disastrous consequences if a facility is not fully prepared for a large chemical release. The fires and explosions at Formosa provide compelling reasons to analyze vulnerabilities that could lead to a major chemical accident. For more information about the Formosa Point Comfort accident or other CSB investigations, please visit our website at csb.gov.
Obrigado por assistirem a esse vídeo de segurança da CSB.